So previously we were discussing LANs in general and particularly bounded media. And remember, bounded media, whenever you hear the term bounded media, it means cables. Now, that may have seemed a bit foreign to you, except maybe some of you still use wired LANs. But what will be a lot more familiar to you is wireless LANs. And any kind of wireless communication medium is effectively known as unbounded media, which means that there are no physical cables or wiring. They generally just use radio technology. And all of your different radio frequencies determine whether you're using Wi-Fi or WiMAX or 3G or HSDPA or microwave links or whatever the case may be. But this particularly revolves around wireless LANs, which uses Wi-Fi routers, and Wi-Fi is a standard throughout the world, and the IEEE number is 802.11, and there's A, B, G, and N. It is important to know that it's 802.11 because sometimes that does come up in exams, so just do take note of that. So obviously wireless networks have some advantages over wired networks, but perhaps also some disadvantages. But the biggest advantage obviously is that you're not constricted or constrained to some kind of physical location where there's a cable. So it also usually in networks like schools and businesses runs in parallel with a wired network. One of the other biggest advantages is it allows mobile devices, obviously network connectivity, and a lot of your mobile devices, whether it's laptops or cell phones or tablets, don't have network ports. Many laptops do, but those other devices won't necessarily have a UTP port for you to plug a cable in. So they do essentially allow for greater connectivity with a variety of devices. Obviously, there's a huge move towards mobile devices, so Wi-Fi has become kind of bigger and bigger. So essentially we're going to talk about all sorts of things wireless related, but what's important to understand is Wi-Fi does not mean internet. A lot of people are confused by that, simply because when Wi-Fi first kind of started to be used widely, it was used in wireless hotspots, either in kind of internet cafes or coffee shops, and certainly at home if you have an ADSL connection or fiber connection or whatever the case would be, you probably access it via Wi-Fi. There's probably very little cabling in your house. So people tend to think that Wi-Fi is synonymous with the internet, which it's actually not. All that Wi-Fi essentially is a wireless connection to a network. That network may have internet connectivity attached to it or available on it, but the Wi-Fi itself really just connects you to a network. Obviously 3G is different. That is a connection to a mobile network, which usually does imply internet if you obviously have the required amount of data. So this is why this section is termed wireless LANs, because it really does mean a wireless mechanism for connecting to a LAN. You'll have all the exact same features and functionality that you would with a wired LAN within a network. So wireless is just a way of connecting to a particular network, whether it has internet connectivity or not. So a real important part of wireless LANs is a wireless access point. And wireless access points are only wireless for the devices that connect to it. So you can connect wirelessly to a wireless access point, but that device needs to still be connected to the main network. It doesn't just sit there and is wireless, and once your tablet or your phone or your laptop communicates with that wireless access point, that doesn't automatically mean that you're connected to the internet or the rest of the network. that wireless access point needs to be connected to the main network in some way. And usually it is connected using a wired Ethernet network. So if you go and have a look at a wireless router at the school somewhere, you'll see a cable coming out of it. And that cable connects it to our traditional wired network in the school. That is the way that the wireless router itself communicates with the rest of the network. It communicates with the rest of the network. It communicates with the rest of the network using the wired network. So, as you can see from this diagram below here, this is your wireless access point, okay, abbreviated as AP, sometimes called a wireless router, but that is it's a bit of a misnomer, which we'll deal with later on. So a wireless access point, you can see all of these different devices are communicating with the wireless access point, but it is still linked to the rest of the network. In this case, if this is your network at home, your wireless access point will be connected to a router, which will be connected to the internet, and it will be connected by means of a cable. Sometimes this router and this wireless access point are one unit, so you can't see the difference between them. So you'll have your wireless access point and your router in a single device. But for the most part, in schools and businesses, you'll have a number of these access points all connected via cabling to the rest of the network. Now the rest of the network can be, it'll connect to another switch, or it'll connect to a router, but most of the time it connects to other switches, and you'll have your wired network all up here with a bunch of wireless access points which are required to service the entire network. Obviously we have multiple at school across campus, but you can generally connect to any wireless access point, and that is connected to the rest of the network via cabling. Hotspots are a bit different because a wireless hotspot implies that it has internet connectivity. So when you go to a coffee shop, or if you're in a shopping center and they have free Wi-Fi, that is called a wireless hotspot. It is kind of different from a wireless LAN, because a hotspot does definitely imply wireless internet access. And this could be free or paid for, or whatever the case may be, but it does require some kind of username and password. Sometimes they have free trials. But when we talk about a wireless hotspot, that does imply free internet connectivity in some way, and it's usually out in public. Whereas a wireless LAN is not necessarily connected to the internet, but more often than not, it is. If our internet connectivity at school goes out, so in other words, there's no internet connectivity yet, we will still have wireless access to the rest of the services on campus. You can still access your mail because it's on the network. You can still access file shares on your friend's PC. You can still play network games. You can still access your iDrive, Moodle. There are a variety of things you can still do even without the internet, because a wireless access point gives you access to the LAN in a wireless manner. So it gives you access to the network without having to use a cable. The internet happens to be one of those services that we can access via our network. Whereas a wireless hotspot does imply a link to the internet explicitly. You've got a little diagram over here, and you've got your wireless hotspots. You're obviously in a place like a hotel or a shopping center or a restaurant or an airport. You won't have access to the wired network. Some hotels do, but generally you won't be able to plug in the cable. You will have to access the network wirelessly, and it will have internet connectivity. Now, I did say that usually a wireless access point on a LAN is connected to the rest of the network via a cable. There is an exception, and that's called a wireless bridge. And what a wireless bridge is two specialized network routers, which are wireless, which basically link two segments of the network. So if you've got a place where you can't lay cabling, it's too far away, you can use a wireless bridge. And in that way, you can have two different parts of your network linked wirelessly. In fact, a lot of your wireless access points can also do bridging. In other words, you can set it up without an Ethernet cable to say, well, look at the next access point to get your internet access. Now, the disadvantage of that obviously is because it's a radio signal, Wi-Fi has limited bandwidth, and the bandwidth is limited to the radio frequency that it works on. So your standard Wi-Fi that you got a few years ago was 54 megabits per second, and the first person to connect it would get 54 megabits per second. If two people connected to it, they'd each get 27, a third person who would divide by 3. So you had to share the bandwidth. Whereas with a wired network, you each have a cable, so you each get that 100 megabits or gigabits directly at the end of your cable. So if we use our wireless access points in bridging mode so that it connects to another wireless router, another wireless access point, without being connected via a cable, a lot of its bandwidth is used to make that bridge. So a lot of the bandwidth will be used to connect those two things together. So that's why it's generally preferred that it's connected via a cable. But sometimes if you have two buildings with a road in between them and you need to connect them, a wireless bridge can be very useful. And you also get long-range wireless bridges, which can bridge, let's say for instance we wanted to make Clifton Nottingham Road and Michael House's network one, we could set up a long-range wireless bridge between the two campuses. So in that case, to connect the two networks at Clifton and at Michael House, we wouldn't need an internet connection or use our internet connection to do that. We could really just use a long-range wireless bridge. Now, a wireless mesh network, you can actually set that up without having very many wires at all. So you can get a whole bunch of wireless access points all to talk to each other and to share network traffic between each other without cables. It's not very common, but it can be done. So each of those particular access points on the network will be able to communicate with any other node by making its data packets hop between wireless access points. Obviously, access speed on those networks are not great, but it is great for rural areas or places where there's lack of infrastructure, where you do need connectivity over a large range, and then you can just use wireless access points or nodes to transmit data from one node to the other. So this can span quite large geographical areas, and it requires a lot of programming as far as routing that data from particular access points to other access points, but it is becoming popular in areas. So, for instance, here's a little bit of a diagram for you. You've got all sorts of different wireless access points or routers, and they're all connected to one another. So you can see that only 2 of them are really connected to the internet. But if you have a device that's communicating with this router down here, even though it's not connected directly to the internet, it can find a route between all of these routers because they're all within range of one another, and you can go ahead and hop along. So this router will pass your request for the internet, for the web page or particular internet service to this router, which will pass it on to that router, to that router, to that router, and then the internet. So instead of having cables between all these different nodes on the network, they communicate wirelessly. Obviously, remember that does limit the bandwidth of each of these, and it can be slow, but it's better than no connectivity at all. Another wireless technology that's used is Bluetooth. Now, Bluetooth works on quite a high frequency, and it's quite short range. So you've kind of got a 10 to 20 meter range in order to use your Bluetooth, and this is usually used in a PAN, which stands for Personal Area Network. So it's used to connect your individual personal devices together. I don't really use Bluetooth all that much. I know that some people do. You've got a megabit per second, which isn't a huge amount, but it's enough to transfer a file or a few photos, or to send a request for printing, or to use a Bluetooth headset or any other Bluetooth devices. So you essentially need to pair the devices with one another. So each of them needs to accept that they are being paired with the particular controlling device in question, so a cell phone and a Bluetooth headset, or computer and a cell phone. But it is a very short range technology. It's wireless, it's cheap, and it's fairly easy to use. So you can manage a kind of a megabit per second and upwards, and it is quite useful for connecting all your personal devices together. So the next thing that we need to chat about, because we've discussed LANs now, is WANs. Now, a WAN stands for Wide Area Network. So what that means is the network is still essentially within a particular organization, but it spans a much larger area. So if you think about, for instance, the traffic department, they will have a WAN, or a bank, for instance, like FNB, they'll have a WAN. So for instance, if you go into the branch in Sandton, their computer system will be connected in a LAN, so all those computers will speak to one another. But their network extends to all the other branches in Cape Town and Durban and Kimberley and Bloemfontein, or wherever you are. They all share a common network. Now, obviously, that huge network is not really connected via UTP cable or even fiber optic, but it will use an internet connection in some parts, so in order to create a bigger network. So if network traffic in Sandton, let's say for instance, a network request is sent out on the network, it'll eventually get to a point where it realizes, okay, the address that I'm looking for, the server that I'm looking for is not on the premises. But it will still look for it on their wide area network. And that happens almost seamlessly. For the computers on the LAN or local to the Sandton branch, it's the same thing as if the computer was in the same building. Except that FNB is using some advanced servers and telecommunication equipment in order to link their individual branches and their data centers around the country via an internet connection. But it is still one network. So that is essentially what a WAN is. It is a network that spans a wide geographical location. Okay. So devices that are needed to connect different segments of a WAN, and we talk about segments of a WAN, you can think about different branches of a traffic department or different branches of a bank, but we definitely need gateways. And a gateway works in a way, in the same way kind of that a bridge works, just on a larger scale. So each of the branches will have a gateway, and they will know what's internal to the branch and what's not. So that branch will have its own servers, its own computers, and any traffic which is destined for a node within the same branch won't reach the gateway. But as soon as it's trying to access something from another segment of the WAN, it will go to the gateway, and the gateway will then send that data to the appropriate part of the WAN. Sometimes WANs are connected with other things like microwave transmissions, undersea cables, etc., but the way it's connected isn't nearly as important as the structure of the actual WAN. You can see here is a picture of all the submarine cables, which are used mostly for internet connection, but some private companies do use these cables to create WANs across the world, or sometimes called GANs, Global Area Networks. There's just a diagram of all the different internet connection and cables in and around Africa, and you can see the speeds of those cables. So CCOM, the green one over here, is a big one that we use for our internet connectivity in South Africa. And there are a few others. The SAT3 is also, it's quite an old one. As you can see, it's not very big, but it is growing quite a bit, which is nice. So that was Wi-Fi in particular, and it did touch on kind of some longer range wireless technologies like satellite or microwave or things like that. But there are a lot of different wireless technologies which can be used. So another one which is quite popular is GPS, and that stands for Global Positioning System, and that obviously uses satellites and a very accurate time to plot your position globally. So all you'll learn from that, or all your device will learn from that, is its position. You still need software in order to tell you something about that position, but it is still a wireless technology. And then we start with all the cell phone ones. So GSM, GPRS, Edge, 3G. All you really need to know is what comes after what. Okay, so if you know essentially that GSM was first, and that's essentially it is used for cellular communications and generally voice data and SMSs. That's what came first. Then we moved on to Edge, or rather GPRS, and then Edge, and these are all just faster technologies. You don't really need to know speeds. You just need to know GSM does the voice and a little bit of SMS data and things like that. GPRS is really slow data. Edge is faster. 3G, which was a huge kind of development, which was essentially broadband for cell phones, that was faster. And then we went to 4G and LTE, which includes the mobile WiMAX standard. So all you really need to know is that those are increasing speeds, and that 3G and 4G and LTE and HSDPA Plus and all the rest of it was really where we went high bandwidth with cell phones. And that your cell phone uses that for bandwidth. And then we get to WiMAX. So WiMAX is essentially an extremely high bandwidth connection which is available to mobile devices. And the main difference between Wi-Fi and WiMAX is distance and speed. So Wi-Fi is basically for inside a building or for small areas, and WiMAX is a very high speed connection which can span quite a long distance. Okay, so WiMAX essentially operates like mobile data, but it does allow you up to 30 to 40 megabits per second, even up to a gigabit data rate, and it can be used by a variety of different devices. It's more like, an internet connection than it is a connection to another network. So it provides portable mobile broadband connectivity on a variety of devices. It can be an alternative to kind of DSL or fiber lines. So the school has a WiMAX link with Vodacom, which gives us 40 megabits per second internet connectivity. And you need a special receiver and transmitter in order to do that. So we've got dishes outside of the school and things like that. It's not just you can't just get WiMAX on your cell phone really in its purest form. So if you want to use it as an internet connection at home or at an institution, you are going to need specialized equipment. And that brings us on to more about kind of mobile technologies, seeing as though we're talking about Wi-Fi. And a lot of this is about smartphones, and it's covered in more detail in the hardware section. But essentially what you need to know in mobile phones is they do have specialized software which helps you to connect your mobile phone to a variety of different connectivity or connection mediums. So your phone will handle Bluetooth, it'll handle 4G or cellular data, it'll also handle Wi-Fi. And the operating system and the browsers and things like that are all kind of built with that in mind. And bandwidth really has driven the development of the smartphone, because the more bandwidth we have, the more we were capable of doing on phones. We were capable of streaming videos, watching videos, surfing kind of high interactivity websites. With the advent of apps, we obviously needed better resolutions, better operating systems, more memory, faster kind of Wi-Fi connections, better settings, and things like that. So all of that did effectively drive the development of mobile operating systems and the software on mobile phones, and you can go and read up on that on your own. It's not terribly complicated. So we've essentially discussed how you connect to a network. Is it wireless? Is it cables? What devices do we need in order to connect? What type of wireless connections are available to us? What type of wired connections are available to us? How are networks laid out? So in terms of its topology, and we've talked about things like Ethernet and how we access a particular wire, so the media access methods or techniques. And now we're going on to much more of a software-based information on networks. And one of the really important things to understand is protocols. And protocols are really rules for data transmission on a network. And there are tons of different protocols. And the ones you really need to know are SMTP, HTTP, FTP, and TCP/IP. Those are the main ones. And these are all rules for how data is communicated. And they work at different levels. And this is quite important to understand. So TCP/IP is one of the most basic, well, not basic, it's quite advanced, but it is the protocol that almost all data on the internet and any network is transmitted via. So as soon as a computer wants to use the network, it will use the TCP/IP protocol in order to communicate via the network. Okay, TCP/IP protocol assigns IP addresses. It decides how to package a piece of data to send it. It doesn't care what that data is. It doesn't care if it's a web page. It doesn't care if it's an email. It doesn't matter to TCP/IP. Those are all handled by your other protocols like HTTP, FTP. So any web data, any email data, any video data, any VoIP data, any data you sent on a network is going to be sent via TCP/IP. Okay, and you can really think of TCP/IP as a road. So a traditional road can carry trucks, it can carry cars, it can carry minibuses, it can caters for bicycles and motorbikes. It doesn't care what's driving on it. It's just the road, and there are rules of the road. So TCP is like the road, and you need to follow the rules of the road. You need to drive on the left-hand side. You need to use your indicators. You need to obey a speed limit. And TCP/IP allows a whole bunch of different types of data to be passed along a network. In the same way, the road allows a whole bunch of different vehicles to travel along the road, but it's still they all use the same road. So there's TCP and UDP are slightly different. So TCP is a synchronous protocol. In other words, what that requires, it's kind of like some things need to happen before other things. So what it'll do is it'll have a message which it'll break down into 100 packets, and it'll send packet number 1 to its destination. Then the destination needs to say, okay, I've received packet number 1, and then it'll send packet number 2. And the destination says, I've received 2, it'll send 3, received 3, it'll send 4. So it waits for that delivery notification before it sends another one. Now, the good part of that is that the TCP packets, when a piece of data or a bunch of data is communicated via TCP, it will arrive there in the order that it was sent. So package 1 will arrive, then 2, then 3, then 4, then 5, then 6, then 7, etc., until the last packet has arrived. So it will arrive there in order, and it's very reliable because it requires the destination to confirm that it has received each piece of data before sending another one. UDP is different. It's connectionless or asynchronous. So it will send a whole bunch of packets, and it doesn't really care whether it gets there or not. But it'll send it anyway, and it'll just hope that you get there, and it'll arrive in no particular order, and it's up to the destination to put that information back together in the correct order. Now, there are different uses for these. So obviously, when you're transferring large pieces of data, like on retrieving a web page, you want everything to arrive, and you want to be sure everything arrives. So you use TCP. If you're doing something like VoIP, TCP is too slow for that. So you don't want to have your voice. A second of voice could be 100 data packets, and you don't want it to be slowed down by having to say, okay, have you received this millisecond of voice? Okay, I'll send you the next one. So we use UDP. And because the packages are so tiny, if you land up missing 1 or 2, you're still going to get a good idea of what the person is saying if you're on a VoIP call. So UDP is quite useful over there. But most use TCP/IP except for VoIP and DNS and things like that. Okay. SMTP, POP3, and IMAP are all protocols which are used to deliver mail. Now remember, we said that TCP/IP really transmits anything. It doesn't care what the data is. Now all of these protocols, SMTP, POP3, IMAP, these are all the different types of data that can be sent via TCP/IP. So it really controls what information is being sent via TCP/IP. So SMTP is a particular protocol for sending email, and in order to do that, you'll have to send a message that says, okay, I'm ready to send an email. The server will say, okay, but I need a username. You'll give it a username. Then the server will say, I need a password. You'll give it a password. The server will then say, okay, what do you want to send? And you'll say, all right, I want to send this message to this person with these attachments. And then the server will say, okay, it's sent, and send you a message back. All of that communication is the SMTP protocol, but it's all physically sent across the network using TCP/IP. And POP and IMAP work much the same way. So all of those protocols, SMTP, POP3, IMAP, HTTP, they all communicate via, so in other words, SMTP is a truck, whereas HTTP might be a tanker. They're all using the road, but they all work in a different way. The one carries liquid, the one might carry other stuff, a car might carry passengers, motorbike only carries 1 or 2 people. All the data is being sent on the same protocol, TCP/IP, but they all have different purposes and use protocols on top of that. Then there's also a bunch of wireless protocols, and these also work on top of TCP/IP. And the most popular one you would have seen is WEP or WPA. Those are security keys. They are used to secure wireless networks. All the communication is still done on TCP/IP, but this adds an additional layer of security. So whatever data is sent, it's checked first whether you have access to that network, etc., etc. So all you need to know about this stuff is that the WEP and WPA and WPA2 are used for security when you communicate on a wireless network. And they differ in terms of the amount of encryption that they use. Okay, so WEP really is the original one. It uses a 40 to 104-bit encryption key and encrypts information that's one sent to another. WPA is kind of used as a pre-shared key, so it works on kind of a key exchange, and that is per packet key, and it dynamically generates each one for a new packet. And then WPA2 uses an authorization for it to make sure that you're an authorized user for the wireless network, and it protects people from or protects unwanted people from using your network by having to have a Wi-Fi password. Okay. Right. Once again, those are wireless. Those are particularly, when they say wireless, it means Wi-Fi. These are mobile protocols. Okay, and this is where your HSDPA and USSD and all sorts of things come in to it. And WAP was the first one to be used. So it was a mobile protocol used to browse the internet back in the day. Not really all that widely used anymore. Okay. HSDPA is obviously one of our current ones that is a protocol for transmitting data via mobile technology. Once again, you can still use HTTP across HSDPA. HSDPA, so its connection would be LTE or 4G. You would use HSDPA to communicate with the actual, your wireless or your mobile service provider, but on top of that, you can still use HTTP or whatever the case would be. USSD is quite interesting. It's something you may have used. It's when you dial *100# and then it goes, would you like to, and gives you a menu of options and you reply with 1. Those are all called USSD. They're not particularly user-friendly, but they are advantageous because generally they don't cost anything, and you can top up your airtime or check your balances or voicemail or do a variety, send a please call me or variety of different things using USSD without using your airtime or requiring data, whatever the case would be. Okay, and there's a little bit about USSD messages over there which you can read up on. Here are some web protocols, and they go through them. So these are particularly used on the internet for browsing the web. We did go through SMTP, POP3, IMAP, which are the email protocols, and those also are web protocols. I don't really know why they aren't in that section. But HTTP is the protocol for transmitting web pages. HTTPS is the protocol for transmitting secure web pages, so that has a lot of security built into it, and that's covered in the Internet Security section, I think in the grade 12 book or the grade 11 book, I can't really remember. But these protocols differ. So in other words, there's a different way that you need to check whether you have the right authority to access a web page, to certify that the web page is correct. It encrypts stuff. And once again, all of this data is transmitted on TCP/IP, but they're just protocols for web pages, secure web pages. FTP is for sending files over the internet, and I wouldn't really worry about WebDAV. It's just a communication between clients and servers over the web. And that pretty much concludes a lot of the internet or the e-communications, networking section. And the networking section really deals with the nitty-gritty of networking, so connections and protocols and wires and standards and a whole range of things. The other internet stuff like web browsers is discussed in the next section. So this is really about the nitty-gritty of connecting computers or devices to a network and exactly which mediums they use in connection access or access methods, etc., etc. So that concludes the grade 11 web section, and next we are going to do the next chapter, which is Internet and www, which talks a lot more about the internet itself and not the network communication as such.